Good morning, everyone. I'm Tom Cherryhomes. I'm one of the firmware engineers for the FujiNet project. This particular talk is going to be a bit different than talks that I've given in the past in that it has less technical details and focuses more on the social aspects of our project. In particular, we're basically going to be doing past, present, and future timeline for FujiNet's development. So where did we come from? Well, I had run into a certain individual named Joe Honnold on Atari Age who had been working on an Atari Wi-Fi modem firmware for ESP8266 devices. He'd been working on this by himself. Nobody knew that it had happened. And when I started talking to him, I realized that he had taken and used one of the bigger ESP12 modules that had all the GPIO pins connected to pins on the Atari peripheral port. So I asked a question, is the command line hooked up? Well, on the Atari, the command pin is what is used for peripherals to signal when there's a command available to take and process. And Moswald said, yeah, sure. So I started thinking, could we take and make this little 8266 simulated disk drive? And the answer was, well, yeah, basically we did. So what wound up happening, roughly 3 months after I asked that question, with hard development, we first started booting off of the local file system, one sector at a time, then an entire disk. And then soon enough, we were booting disks off of the network, off of the cloud. And this was actually the very first time that this had been successfully attempted, because as luck would have it, the wire on my development board broke the very moment that we actually got the code working. So I had to take and call him up and go, please, dude, I need you to test this. So we went, tested it. He had the foresight to record it, and this was the very first time that Jumpman had been loaded into an Atari 8-bit from a machine over at DigitalOcean, roughly 1,000 miles away. And it worked. It worked better than I thought we would ever think it would ever work. And that started a series of rapid developments, making the disk emulation faster, figuring out, okay, what else could we take and possibly simulate? I'll scoot up a little bit. But you can see right here, booting up Jumpman. This was the very first time. November 12th, 2019. And it has been an absolute rocket of a ride ever since. So, before we knew it, people started helping. Jeff Piepmeyer, who works at the Goddard Space Center, started taking the bits and pieces of all the Arduino sketches that we had put together and brought them into a framework called Platform IO. Made something that could be eventually production ready. And it was, roughly a year and a half later. Steve Boswell came in and made us our FujiNet logo, and made some of our first hardware prototypes along with Moswald, including the Mars bar. Oop. All right, I didn't change that one. Okay. Oscar, in the meantime, over the next year, we realized that Arduino was not going to cut it for making a production-ready device. So we changed over to use the vendor framework that Espressif created called ESP-IDF. And so many more. And this led to a rapid period of code growth and scaling like we'd never seen before. And in fact, this video right here, I have a link to this video for anybody who wants it, which shows the evolution of the FujiNet code base from its very beginnings all the way up to roughly about 6 months ago. Just rapid code growth, and it is absolutely mesmerizing to watch. You can see as we start with the basic tests, and then over time things modularize. They become components. Scoot it forward a little bit, and you'll see that we've already taken and broken things out into individual components with rapid amounts of development. The move to ASP-IDF caused even more componentization. And eventually, we wound up making it multiple platforms, modularizing here, thanks to the work of Jamie in the back and many others. So it's a great video if you want to see the evolution of our code base as it's gone through. Pardon me, let's scale back again. Not long after we finished the Atari platform and got it into production ready form, which was July of 2020, we started work on the Coleco Atom. And that literally happened because I happened across a technical hardware manual describing how AtomNet worked. And was like, could we make one for Atom? Sure enough. Roughly 6 months later of hard work, taking and reusing the bits and pieces that we had done for the Atari and bootstrapping that, we were able to take and make something that fit into the Atom ecosystem. It looks like a Coleco Atom program, feels like a Coleco Atom program in software. So that you can take and run Coleco Atom software over the network, be able to utilize the virtual printer that we created, be able to utilize the virtual modem that we created, and the network adapter, so that you could have new and interesting networking applications on a machine that never even had an inkling that such things were possible. Such as this ISS tracker right here, showing the position of the ISS, the International Space Station, essentially grabbing a web page, pulling the JSON document from that web page, parsing it, and pulling it down into a form that the Atom can understand. And this is a pattern that we repeat over and over for each individual platform. We try to integrate into the host platform in a way that makes the most sense, in the way that is the most natural for both users and developers. Then one day Moswald says, well, let's try to do one for the Lynx. Why not? Sure, the Lynx has a Comlinks port. Let's see what we can do with it. Sure enough, apologies. Yes, that's supposed to be a picture of a Lynx with the FujiNet running the ISS tracker, which ironically has become the hello world of our little world here. So that brings us to today. Now we have even more pieces of software that we have put together for the platforms that I've mentioned before, and some of the ones that we're currently developing right now, such as the FujiNet Game Lobby, which is a way for FujiNet users to find games that they can play together, and for FujiNet developers to publish the games that they make so that users can find them. We see right here a game of 5-card stud and a series of rooms that the 5-card stud server is exposing. We select one, it automatically takes and mounts the disk image, loads the game in, and passes across all of the necessary session information so that the game can start. Right now, we've done it for the Atari, and this literally just started working roughly 2 weeks ago. 2-3 weeks ago. And the intention is to take and port it to all of the platforms that we currently are bringing up right now and have brought up right now. Not only that, but even simpler examples that even can cross platforms. such as here we have an Atari 8-bit and an Apple II playing a game together over the network. This is a game of Reversi, and it's written in BASIC. For the Apple, it's AppleSoft BASIC. For the Atari, it's Atari BASIC. Two different languages. It doesn't matter, because as long as they speak the same common protocol, it works. And other people have contributed games as well, such as a Mancala game on the Coleco Atom, which we're porting to other machines as well. And so on. And in each case, each of these games are being developed to look like native applications on their respective machines. And yes, because at some point we have to deal with our artificial intelligence overlords. We can even talk to things like ChatGPT. And you've seen, if you've gone out into our display that's out on the showroom floor, you've seen the ISS tracker running on multiple machines as well. And there's also a news reader, so you can read the news. This one's running on a VIC-20, on an unexpanded VIC-20. Think about that for a moment. 5K of RAM. So now, with more programs, we also have more platforms coming up. We just finished all of the work for the Apple II, and it's practically ready for production right now as we speak. Oh, sorry. Here we have an Apple II GS using the Apple II FujiNet running the ISS tracker. And yes, this works on any Apple II with a smart port. So, it means Apple IIc, Apple II GS, and any machine with a smart port card, of which there are half a dozen. So you have plenty of options there to take and put one in your Apple II. Sorry, I keep wanting to hit that. Commodore 64, 128, plus 4, etc. Anything with an IEC port. Just plug into the IEC port and go. And again, we see the ISS tracker running there. And even systems, brand new retro systems, like the RC 2014 and the Agon Lite. And yes, the developer that's working on this took time to port the ISS tracker to do ASCII art. And this is possible because we've done everything with modular design. We separate everything up into completely separate concerns of buses, what you connect to, things like the SIO for the Atari, AtomNet for the Coleco Atom, Comlinks for the Lynx, IWM for the Apple, IEC, etc., etc. And you have the separate devices that go onto those buses. The disk device, the virtual printer device, network device, modem device, etc. And the different media types, which are disk image types, file types, etc., that FujiNet can take and process and send back over to the host computer in a form that the host computer can understand. But also huge numbers of protocol adapters for the network device. And these are just some of the common ones here. You'll notice that I put HTTPS first here. And yes, FujiNet supports crypto. It does TLS and TLS SSL. Not only that, it has channel processors so that it can take and deal with JSON data, with XML data. It can parse that information, and the host computer can query for whatever it needs. So it makes dealing with complex data out there on the web really easy. And we can talk to OAuth, we can talk to all of these things and make applications for these machines to participate on the modern net. We can do all these things together, and that's really the ultimate point here. The idea, I've been saying for the last day and a half here, my goal and our goal with FujiNet is to put a FujiNet on every single machine in that room. I'm not joking. And we have path forward to do this. And once we put FujiNets on there, you can use whatever programming language you want to take and write into. Because again, our goal is to use the idioms that are present on the machine that you're familiar with. Using kernel routines, using ROM routines wherever possible, and only building on top when we need to. Even in languages like BASIC. This is, quite literally, all you need to do to read a single Mastodon post in Atari BASIC. Open the command channel, set it up for JSON, parse the JSON, and then at that point you can query for all the individual pieces of JSON, grabbing that in and displaying it. Simple. And that's how it should be. Finally, for game players, we have this wonderful thing that we call the high score club and high score enabled games, where you can take, if you have a particular game that stores its high scores on disk, you can mark the sectors that are on the high score table as high score enabled. That way, when you put it on a public file server, anybody can connect to it, play the game, and when they post their high score, it will be written to the disk. And I've taken that a step further because we've done a series of games like this on our apps errata.online and made score scrapers for them. So you can go in, and as you post high scores, they get updated, and everybody on the web can see them. And in certain cases, I've even gone through and patched certain games to add high score support, such as with Pac-Man. So these are things that we all can come together and we can have fun doing. So that leads us into tomorrow. Oh, come on, don't. Hello, Emacs, what's wrong with you?
I think it's still running the command.
It might, let's see. Oh yeah, here, let me kill that instead. Yeah, okay, thank you. So that leads us into tomorrow. What's on the plan for tomorrow? Well, more platforms. A lot more platforms. And you may be asking ourselves, how are you guys going to take and pull this off? Well, we've already proven that we can do this for serial-based buses. The next major challenge is to do it for parallel buses. 8-bit parallel buses, 16-bit parallel buses, etc. And for that, we have different teams that are currently doing bring-ups right now. And the most important team in that group right now is the ZX Spectrum group. Because what they're doing is they have designed an 8-bit parallel bus to hook up to the ESP32. They did it in simulation. It works in simulation. They've moved it to breadboard. It's working in breadboard, and now they're moving it to board. And the interesting thing about the first pass of this implementation is that it was done explicitly in just 7400 series logic. And that means that if we want to take and boil that down to a CPLD, we can. If we want to find other ways to take and reduce chip count, we can. But we did all the hard work to try and work this out in discrete logic first. So that means once that's all together, that means now we can hit anything with a card edge. That means isobus. Think 5150 PCs. I mean, these machines really can't get onto the internet for a variety of reasons. Slow clock speeds, no low memory, etc. Put something like FujiNet on them so that they can load software, and we have a foundation where we can take and do interesting internet things with these PCs. And as it so happens right now, I have Macintosh on this list right now, and Macintosh is now being moved up into the active category because as of roughly 3 days ago, the engineer who worked on the Apple II is now working on the Mac, and he did some of the first commits for that just a few days ago. And when we talk about Mac, we're talking about the teeny tiny Macs, the 128s, the 512Ks, the Pluses, the SEs, that really need something like this. Machines like the Atari ST, hooking in through the ASCII and SCSI ports to take and give the necessary connectivity. And even, and we're not kidding here, 8 and 16-bit game consoles. I mention FujiNet for the 2600 and people chuckle. I understand. There, see? Point made. But I'm quite serious. When we have the bus connection, we can make something that works and that makes sense for the Atari 2600, 5200, 7800, NES, Sega Genesis, etc. Put it on a cartridge and bring them into the fold as well, so we can at least play games there. Maybe other things too. All of the retro computing and retro gaming systems. And of course that means even more buses here too. Plenty of things that we need to go into. RS-232C, SCSI to connect everything through. Generic parallel bus like I mentioned before. Even connection interfaces such as GPIB, IEEE 488, so we can get the PETs involved, and we can get the Tektronix machines involved, and the HP machines involved. All of these machines. Why not? It's all there for the taking. That brings us to lessons learned. And the first one for me is honestly the most important. Being useful is better than being fast. I get so much flack for this one alone. Because people are like, oh, why are you going through the serial bus? It's so slow. Why are you? Because it's there, because you can integrate with it, because you can use all the infrastructure that's been in place that was meant to use these peripheral buses. You can use that to bootstrap and present things in a way that logically makes sense for both the developers and the users. Because if you have to take and build your own bus interface from scratch, we're going to have to do that for some of these machines. We understand that. That's fine. But if you try to do that for each and every machine, you reinvent the wheel over and over and over again. For what? So it's fast? Okay. But it's not useful. You try to integrate wherever possible. Find every single integration point that you can possibly find to be able to take and bring something in. If you can simulate a disk drive, do that. If you can simulate a printer, do that. These are things that people want to use on their machines, and to make these machines all the more useful, find every integration point that you can possibly find. And finally, realize the feature that everybody wants and make that feature work as amazing as possible. And for us, that was the disk. Being able to take and load software. And to be able to, for someone to be able to say, I want to play this game over here on this machine. I don't have a copy of it. I just want to play it and see it. Bam. Go out there, reach out, mount it, play it. Not having to copy it over, not having to just stream it over. Play it. And that feature worked out rather well, I would rather think, because, I mean, as of this last week, there's about 5,000 Atari FujiNets out there being used. So I think this speaks for itself. Finally, I wanted to give a thank you individually to everybody on this list, because without these people, FujiNet would not exist. I'd like to thank Joe Honnold, Moswald. We know him as Moswald. He is our hardware designer extraordinaire. Surface mount genius like you would not believe. He knows how to take and build hardware. He knows how to take and do the enclosures. And to build something that is producible and is serviceable. And his work on building all the different hardware versions of FujiNet has just been absolutely wonderful. Jeff Pietmeyer was, I told you before, the guy who literally took and brought us into Platform I/O, which was one of the best ideas that we could have had. Because I don't know if we could have ever survived keeping FujiNet as a gigantic Arduino sketch. It would have scared the crap out of me. Andy Diller has been absolutely instrumental in evangelizing, in getting us into VCF, starting with VCF East, in helping test all of the different versions of FujiNet, in providing ideas and being a good sounding board for as we build things off of. Oscar is I really want to mention Oscar here, because Oscar literally took our Arduino code that we had moved into Platform I/O. We were still using the Arduino libraries at this point, and ported it to ESP-IDF over the period of about a week and a half. Ported the whole thing wholesale, top to bottom, himself. And it worked the first time. Amazing. Jamie Johnston has come to us courtesy of the Meatloaf project, which is a similar project for Commodore 64 machines. Started out on the ESP3266. You know, the funny thing about all these retro computing projects is that they often happen in isolation. You've got people working off in different corners. You don't know what people are working on. So if they happen to come across you, there's this look of surprise of, hey, I'm working on that too. But most amazingly, he said, well, hey, let's work together. And so he's come over and he brought his wealth of code and experience to make the Commodore version of the FujiNet even better. And he brought over the Meatloaf libraries, which we're going to be transitioning to for all of the targets, because he's built classes for interacting with disk images and peering inside of disk images, peeling them back, even if they're encased in 7 layers of zip files. I mean, did a fantastic job making all of that work. And it's something that we really absolutely should leverage. William Schaub has absolutely been instrumental in making sure that the Apple II version of the FujiNet works as expected. I've worked with him before on other projects, and he has an uncanny ability to take and detect a problem and to get right to the root of the problem and find the most obscure pieces of documentation on this planet to validate that it is a problem and then fix it. It's amazing. Norman Davey, industry veteran at places like Electronic Arts and whatnot, has been instrumental in helping us write game servers and various games, various applications that FujiNet will use. Marcin helped us basically add on Bluetooth capability to the FujiNet for the Atari so that you could use SiO2 BT devices. Mark Fisher is helping us a ton with the web UI that FujiNet has, and making it absolutely modular to deal with all the different platforms, making it work well, making it work, just doing a great job there. Steve Boswell, who I've mentioned before, case designs, initial work, etc., logo, everything else. Frank Rachel, he has been instrumental in maintaining the cross-platform configuration program that we carry from one platform to the next, and making sure that everything is nice and neat, compact, clean, working well. Eric Lebras has been doing amazing work in making sure that the FujiNet works well on the Apple IIgs, building control desk, control panel accessories, new control panel accessories, and example programs and the like. Rob Justice is the reason that the Apple II version of the FujiNet works on the Apple III. No joke. SOS drivers and everything. And Owen Reynolds is the guy literally behind doing the ZX Spectrum version of the FujiNet and the 8-bit bus interface that we are going to take and use this to go on to every other platform from this point. And so much more. So many more people. And if you want to take and join too, you can. We're all just a big happy tree fort trying to take and make something awesome. So how can you help? Well, you can go onto the Discord here, and the Discord has many different channels for different platforms, for the different projects that we're working on, etc. You can also take and make new application code that runs on the machines themselves. And these will wind up in FujiNet apps for other people to look at and build examples out of. You can help make hardware. There's a hardware repo which basically contains Gerbers. It contains bill of materials. It contains schematics, because we want people to take and build these devices. We don't ask for any licensing. We don't ask for anything in return. We just want people to take and build them. And we want people to help, especially to help on the firmware. Because as a matter of perspective here, we're only using 1/3 of our available memory space in our firmware. We still have plenty of room to grow and add new features, add new protocol adapters, add things we haven't even thought of yet. I mean, as a crazy example, we took the SAM speech synthesizer. Somebody had translated that from 6502 assembly into C, and we threw it on the FujiNet and made it work over a weekend. More info, of course, the main website, FujiNet Online, which gives you pretty much anywhere that you need to go so that you can see what's going on, but also if you want to take and be able to get a FujiNet, it gives you links into our wiki, etc., etc. It's definitely, this is the main place to be. I know I started, wow, okay, and I've officially taken and done this faster than I had hoped. So that actually leaves some room here for questions or things that you guys like me to cover. Anything at all.
I'd like to compliment your use of Emacs to do a presentation. I thought that was fantastic.
Thank you. So, made it efficient, didn't it? So, like I said, yeah, go ahead.
Does FujiNet have the ability to, I hate to ask a very platform-specific question, but
go ahead.
A lot of us have C64s out there, and the disk drives are beasts. They weren't necessarily disk drives; they were their own computer.
Yeah.
Are you able to mount disk images that have the original, all that nonsense, copyright,
copy protection?
Yeah, copy protection in there, and emulate the drive, or is this really just I/O for raw sectors on the disk that need to be used by a client software running on the retro host?
For each for each target system, we implement the bus implementation, and we implement the devices that absolutely need to make sense for each target system. It just so happens that for the Commodore, for the disk drive, you have to implement a whole lot. And we actually implement, we don't implement any of the copy protection stuff yet. We have a framework in place to be able to handle those disk images. But that code needs to be implemented. That means the ESP32 is more than capable of simulating a 6502 cycle accurate, and it's more than capable of implementing the native VIAs, etc., to be able to do the I/O back and forth. So this is something that's on the roadmap to do. Seeing as the majority of software that you can get for the C64 has been cracked, that's not really an issue. So, we will take, and as we fill out these platforms, these new media types will be added.
I guess I should have reframed the question at a more basic level. Does the FujiNet appear as its own device to the machine, or does it emulate, an original printer, an original disk drive?
Both.
All retro software doesn't have to know anything about a FujiNet. It just peripherals there.
The simplest answer to your question is both. It does both at exactly the same time. So, for example, you mentioned the Commodore 64. It emulates it has a printer on device 4. Right now, MPS 803, FX80, there's a handful of printers that it can do. It has disk drive devices for 8 to 11. Okay, so 4 disk drives there. It has a network device, and the network device is literally you give it a network endpoint, and it's an I/O channel that you can talk to. The behavior of that network device depends on the protocol adapter that you use. So if you want to take and bring in a basic program over a TCP connection over Netcat, you can, etc. So you have basically the best of both worlds, and we did that because we were able to do that because on the Commodore 64 we implemented it as an IEC device, as a set of IEC devices that talk over the kernel.
Is there any development on the Zorro bus for the Amiga?
Not yet, but we would like there to be. Now that we have a viable parallel bus interface that we can go forward on, that is an interesting possibility. And yes, for anybody who wants to help with doing a system bring up, come into the Discord. We'll take, and my job most of the time when I'm not doing firmware engineering is trying to take and facilitate and make sure that the people that are doing the bring ups have everything that they need to be able to move forward. Yeah.
You mentioned printer. What does the output look like? What is the end result of using it as a printer?
Yeah, so you get a PDF, and the best way I can do that, I'll take and pull something that I've got on my Google Drive here. I've saved a PDF for some bits and pieces. This came out of Print Shop. And what's happened, so...
You're even emulating broken pins on your printer?
Yes. Well, no, that's literally that's an artifact of being zoomed in. But if you were to take and zoom into each one of these right here, there's a dot there. There are individual dots there for every single pixel. So yeah, we model the dots.
So when you emulate a printer, you're emulating its output?
Yes, quite literally. You pick the printer, data stream comes in, the FujiNet takes and renders that to PDF. You take that, print it on a modern printer.
What if you're printing a text stream where you expect the printer itself to do the character generation? Can that come out as a text file?
Yes. Yes, that's extremely useful. So there are different printer types, and one of those printer types is quite literal. Well, there's a couple of them. You can either get the raw printer output if you want it, or you can have it say just convert that to ASCII. And not only that, in the case of the Atari, for example, we did what was called an ATASCII printer, which takes and uses the ATASCII character set to output an HTML page that looks like whatever you send to it. It's good for listings. Yeah.
Is there anything on the roadmap for doing, like ROM cards, supposing like, a Atari 2600 cartridge or a C64 cartridge, so when you power the machine on, the software's running?
The ROM card, the 8-bit bus interface will allow us to take and make something that works for game consoles and the like. And as for anything else, that's for a system bring up guy to take and come in and try to do. Yeah.
How was the SAM speech synthesizer implemented? Just kind of on a pin, kind of generic.
Yeah. So in a very basic sense, the SAM was disassembled into 6502 assembler code. That 6502 assembler code was translated instruction by instruction into C. That C code was then wrapped into a library, and I brought that into the tree and into our code tree. And what we did was we hooked it up. The FujiNet has a DAC on it, so we just hooked it up to the DAC. And on the Atari, we hooked the DAC pin up to the audio pin on the SIO. Just worked. Literally first time.
So that leads me into another question. So that allows for audio playback from cassette. If
Yes.
it decides to
Yes, exactly. We do have an FSK decoder. We do have an FSK decoder implementation in FujiNet to handle cassette emulation as well. So that's the first part. The second part is literally taking and synchronizing that with the audio channel output here too. It's possible. Somebody just needs to roll up their sleeves and do the work. That's it.
I like the way that you present that. You make it sound like, oh, it's just a simple matter of doing it, which tells me that this is very well managed.
Well, I'm trying to. We're trying to. And the best thing that I can say is that we've provided a whole set of tools and bits and pieces in which to take and make all of these things possible. And for many of us, we've done a lot of these features ourselves, but we would like other people to take and come in and try to take and implement features too, because we want anybody who wants to be able to hack on this.
I'm trying to compliment you, and you're deflecting the compliments.
Thank you. Thank you. That's okay. So, any other questions?
What is the guiding principle? And pardon me, I didn't hear about FujiNet until I walked in the door. Is the guiding principle more about we want to make all these dissimilar systems useful with each other? Or is the principle to, hey, let's just replace a lot of hardware and make it one project, and you can use the little bit that you're interested in?
Well, the guiding principle is actually the former. The latter is kind of a side effect.
Is that where the majority? I mean, obviously you got to development to make the device work, but is there different efforts being made that say, I don't care about hardware. I want to talk about human beings interacting with dissimilar systems.
Yes.
And let's make some content. Let's make some portals. Let's make some stuff that makes it interesting to actually use for a Atari versus Commodore guy, so they can have the flame war online rather than over the internet.
That's all. Yeah. If you want to have the flame, that's the thing. All I'm trying to provide is the necessary infrastructure for all of these different machines to be able to do something fun together. Because I hear it over and over and over again. That people like, I love my machine so much, but I want to be able to do useful things with it. I want to be useful. Better to be useful. So, yeah, that's our goal here. And between all of us that are currently on the project, we have the experience and the insanity level to actually be able to take an attempt porting this thing to potentially hundreds of platforms. All the infrastructure is there, and it's out in the open. We've given ourselves roughly a 10-year goal to be able to pull this off.
Do you have, I didn't know if you showed an example of the menu for those that haven't seen it,
Okay.
and show maybe that menu?
Yes.
Like the Atari? And then
Absolutely.
Maybe the web server menu?
Absolutely. The beautiful thing here, one of the things I didn't mention, was that in addition to having the hardware FujiNets, if your emulator supports the ability to do external devices, we can hook onto that as well. So we have basically FujiNet attached to Altera running an emulation. So you have the full bear of using all of Altera's resources, including the debugger, including Altera's excellent debugger. So what has basically happened here, anytime you turn on an Atari, you slap a FujiNet onto the back of the machine, you turn on your Atari, this is what you're presented with. You have a series of hosts that you can connect to, and you can edit them, change them up, do that sort of thing. And you have the ability to select one of these hosts to go in and view what's on them. Is it going to let me do this, or am I firewalled off? Hold on a second. Let me see if I can switch networks real. Can I? It's not going to let me. I'm firewalled off. No. Well, okay. Yeah. It's not going to let me do that. We're going off script. Okay. So
one of those hosts could be another system,
yes,
a Raspberry Pi on which
a Raspberry Pi on which you have your local file storage. It could be an internet host. There's a handful of TNFS file servers out there that have stuff for multiple platforms. It's all out there too. And let me see.
Bring it up and show the web interface though, right?
Yes, I will. Yeah. Try that one more time. So once FujiNet is actually running, oh come on. It's a good thing we have a few moments. Get out of here. Don't do this to me. Demos, love them, right? Come on. You can do it. So while this is running here, we'll go to the web interface. And the web interface basically allows you to take and do mount disks from host slots and do most of what you can do in the config, but also from the web. So you can do it outside of that. But also provide a way to pick up your printouts when you have them done. Set your printer types. Turn on and off virtual modem settings, including a modem sniffer so you can capture traffic, and so on.
Printer question. Can you set it up so that whenever you're trying to print, that it is intercepting that printout as soon as possible and pushing it to a real printer?
We don't have any feature for that. If someone wants to add it, go for it. I wanted to take and make something that would work for everybody for the first pass, so to speak. So, yeah, web interface. Everything you need. We tried to provide as much useful stuff out of the box that most people would be able to use.
I see your 1.2.3.4 that you put in is already visible here.
Yes. Yes.
Well, I mean, this has been useful. I mean, on like the GS, is you don't have to restart.
Yes.
You don't have to reboot the whole machine and turn it off to bring back the FujiNet menu. You
Correct.
Can just go into the web interface, load your image in, and then you got it.
You've got it.
Yeah.
Absolutely.
So
especially under GSOS.
Yeah, especially in the GS.
Absolutely. Is it going to let me?
What's your biggest challenge right now?
Biggest challenge right now is God.
That's a hard one.
That's a hard question. That's a good question. Not really big challenges, but lots of little ones. Just trying to get all these platforms to a point where they can be brought up, getting all this necessary information in so that we can do it. Trying to make sure that the people that are helping with the bring-ups have everything that they need, and yeah, that's really, trying to get people to. It's hard to get people to take and come in and help, which is why I am so thankful when people actually do, and why I take the time out to thank them. So, very fortunate that we have as many people as we do working on this, as we do. Okay, well, any more?
Do you feel like you're able to keep up with demand?
That's been an interesting issue. Oh yeah, okay, well I'll say that as well. The way that FujiNet production actually happens is a bit different than most other open source or hobby projects like this. We only build enough units, Maswell only built enough units to take care of his development costs. So what we do instead is work with vendors in each individual community, the vendor stores, etc., the ones that can make these things, to provide them for their respective communities. And the thing that we would like most is for vendors who can do the soldering, etc., or who can build these things, to build them for their respective communities. As far, and yes, on the Atari one, to really answer your point directly, every time that someone would put up a run of FujiNets just on Maswell's own store, they would be sold out in 20 minutes. And that happened for about 2 years straight. And, and we had, Gavin Hobbolt out in Vintage Computer Center out in California who was selling these things like hotcakes. The Brewing Academy still sells these things quite regularly. Like I said, there's about 5,000 of these units in active use out there right now as we speak on the Atari side. I think that number, once we bring some of the other platforms in, that might dwarf things a bit, 22 million Commodore 64s. Who knows? So, yeah. It's been interesting to try and keep up with demand, for sure. And trying to get people to build them.
Out of curiosity, it seems Atari based. Is that just because that's your flavor of choice? Was there a reason behind it being?
It was where we started, and yeah, Atari is one of my favorite platforms. But I really need to stress that we started there, and we decided that we had what we needed to be able to take and move it over to other platforms. But it's just how it happened, and it had the serial bus, it had the good operating system integration, the central input-output system. So that made it made it comfortable for us to actually start thinking very abstractly on the types of things that we could actually take and implement. I think if we had implemented it on something else, let's say a ZX Spectrum, it would have wound up quite different. Anything else? Okay, then I guess thank you very much for letting me speak.